Hi everyone, I wanted to make this video to go over the changes to handplane 1.4 and to show how some of the new features are installed and used. So first off, here's the changelog. We removed the license system for our transition to freeware. We improved the handling of smoothing groups related to in-real output, and this is if you had issues where there would be hard edges in your tangent space map, like splits along triangulation. This should fix that. And we created a handplane source tangent space plugin for XNormal, along with an SMD importer for XNormal. And then lastly, there's some minor UI tweaks. So if I bring in the new build of handplane to take a look at, you can see there's two major changes. We removed the license system, which you can see at the top. It says full commercial license, and everyone's will say this. And we've also changed the auto detect. So when you go to click the dropdown for baked in, this is the only option available, unless you expand the more options rollout, and then you get all the options you previously had. The reason we changed this is because the most common support request I get ends up having to do with people not setting this to auto detect or wondering if their 3D package is compatible because they don't see it on this list. I also want to quickly cover how to set up the XNormal plugin and how to get the correct results out of it. So I'm going to launch XNormal. And in order to install this plugin, what you do is you install the correct version of XNormal ahead of time, and then when you run the handplane installer, you'll be prompted for the plugin to be installed. And the version of XNormal you need right now is the latest version, which is 3.186. And every time XNormal releases a new version, we're going to recompile our plugin for the next XNormal version. But basically, to set this up, you click this plug down here, and under TB calculator, instead of MIC T-space, you select handplane 3D source engine tangent space calculator. And now if you bake a tangent space map, it'll be baked straight into source engine tangent space. There are a few considerations you need to make here. So first off, the way the source engine works is that it imports mesh normals and it calculates tangents. And that's important because when you make your tangent space map and when you send your model into source, you need to include the mesh normals. So you can use pretty much any file format as long as you are actually including the mesh normals and not just the smoothing group information. So again, source engine imports normals, so you absolutely need the normals when you bake, and it calculates tangents, and that's what the handplane plugin does. It calculates tangents to match the way source calculates tangents. Making this slightly more complicated is that XNormal will entirely skip the tangent space calculation process if it finds tangents in the mesh file. It'll just bake the ones that are in the model, and that won't work. So in order to get the correct result, you need to use the correct export settings. So I'm just going to quickly cover some of those here. So for FBX, the critical thing is that you do not check the tangents and binormals box. If you check this, you will not get the correct result. And then for XNormal's SBM format, you want to check export UVs and export normals. You do not want to export the tangent basis. That'll also break the result. And then this should work with any 3D format that XNormal works with, so long as that 3D format does include the mesh normals. And we've also included the SMD importer. So if I export an SMD from 3ds Max, these options are fine. The explicit normals method doesn't break anything. I click OK. And I go into low definition meshes. You can see that SMD files are now on the list of models that can be loaded. And one minor issue I've had with SMD files, this isn't related to the importer, it's just the exporter, is that in 3ds Max when I export SMD files, they end up getting YZ flipped, so the objects are on their sides, so that can make things difficult to get lined up. But depending on your 3D package and what tool you're using to make your SMD files, that may or may not be an issue. And then lastly, if you want to use OBJ, you can. OBJ is something that comes in a lot of different flavors, so not all versions may work, just whatever XNormal happens to be compatible with. So if I set up an OBJ file from 3ds Max, I'm using these settings. So I set it to preset Maya, and that works very well. But ideally, you should really be using the same model format or even the same model file for your bake as you use to do at least a test in the source engine. And then the last thing I wanted to cover was something we ended up not changing in this build, and that's if you've done source engine bakes or source engine conversions with handplane, and you've been working on something like a sword or something else that has extreme acute angles, and you've smoothed that, you may have seen these sort of patches of inverted colors near the sharpest points of your model. And this is something we worked on quite a bit, and came to the conclusion that this is actually the correct behavior. So I have some images to demonstrate that. So here's an example of that behavior. You can see these patches where the colors are inverted and they're not contiguous to the rest of the normal map. And this looks really wrong, but in actuality this is what the source engine expects. So we did correct what we thought was a problem here. If you scroll up, you can see this is the corrected version. And you can see the colors are contiguous and this looks right, but as a result, where this patch was here on the model, you can see inverted normals. And we found out the reason why this happens is that the source engine doesn't split tangents at extreme angles. So when you have these sort of very sharp, narrow, acute objects that are smoothed, it's possible for the mesh normals to be facing the opposite direction as the mesh tangents as they're calculated. And as a result, the calculation creates these inverted colors to compensate. So while this looks wrong, if you look at the model, it's actually more correct. So you compare, black spot there, black spot there. And here's another example. So you can see this is the area that the colors inverted. If we scroll up, this is the corrected version. And now if we look on the model here, exactly corresponding to where this edge is, on the model you can see the horns have this edge on them, and this blue color is the light color coming from the opposite direction. These are inverted normals. Whereas if I scroll down to the version that handplane creates that looks wrong on the normal map, it actually is correct on the model. You can see it's nice and contiguous. So this still can create some minor artifacts. If you look along this edge, it's possible for these two colors to get interpolated as they get texture filtered, and that would create a very small line of pixels that are incorrect. And if this is a problem, there's the easy solution would be to just add a smoothing split, say somewhere along this edge. So you just add a hard edge here so that the normals can face the same direction as the tangents. In practice, I haven't been able to notice them. On this model, it's not particularly noticeable. On this model, you can't see it at all. So it's really going to depend whether or not it needs to be fixed or not.